Set up but do not evaluate an integral that represents the length of the curve. Here x is equal to 1 plus e to the t, y is equal to t squared. T ranges between -3 and 3. We have a set of parametric equations, and to find the length of the curve in parametric form, we apply this integral formula. The integral from a to b, square root dx dt squared plus dy dt squared dt. So in order to get this done, we need to find a few things. We need to find the limits of integration, a and b. That's quick enough. We know that the limits of integration should be the endpoints of that interval from -3 to 3. But we also need to find dx dt, the derivative of x with respect to t, and dy dt, the derivative of y with respect to t. So we get that done. X is equal to 1 plus e to the t. And let's go ahead and write y is equal to t squared. So dx dt is the derivative of 1 plus e to the t with respect to t, and that's just going to be e to the t. The derivative of 1, of course, is 0. The derivative of y with respect to t, y is equal to t squared, so its derivative is 2t. Now we can put these things in to their appropriate places. So for our arc length for this problem, the arc length is the integral from -3 to 3. Those are our limits of integration. Square root dx dt squared, so e to the t squared, plus dy dt squared, which is 2t squared dt. Now one could simplify this a little bit. The integral from -3 to 3, square root of e to the 2t. Remember, when you have the power of a power, here we have t as a power, and then we're squaring that whole thing. You multiply the exponents, plus, in this case, we would have 4t squared. So here's our integral, which represents the length of the curve given in parametric form, where the parameter t runs from -3 to 3.